Hi guys, today we are gonna go through the value of money, and we are gonna see how money is changing by time, with respect to time, and then how we are gonna determine the value of the money. Let's start our class, and then we will depict all the corresponding money in present, future, and if it is in series. And then I will solve some example in order to depict our class. In order to understand time value of money, let's have two comparison. The first one is present. If you take 165 million right now, the other one is, and a given offer is for 10 years, every year you get 20 million. So when you multiply 10, you are going to get $200 million in 10 years. And then present right now, if you take, is $165 million. So which one would you take? Or which one should we choose? Depends on what is the interest rate. Depends on the opportunity. Depends on lots of stuff that we cannot cover right now, right? Or we cannot, we couldn't think of it. So maybe 165 million is better than 20 million every year, or maybe 20 million is every year is better than 165 million. Depends on the opportunity, as I said, but in this engineering economy, we are gonna depict if the interest rate is some certain number, what will we choose? Just purely depends on the interest rate. So we will go through all this and then we will understand better. And let's define some terms. Money has a time value because it can earn more money over time, learning power. It means earning power, right? And the other one is money has a time value because it purchasing power changes over time, which means inflation or deflation. And also time value of money is measured in terms of interest rate, as I depicted right now. And interest is the cost or price of money across the borrower to the borrower and an earning for the lender. So if we explain one by one, we say the money has a time because it can earn more money, depends on the opportunity. Okay, like you can put your money on gold, you would predict the gold is increasing than your exchange rate. Or you know that you can purchase right now a computer with a certain money, like let's say 10,000 Turkish lira right now. But due to the inflation, in 5 years, you are gonna get, like, with the 10,000 Turkish lira, you will get maybe the just a workstation, not the complete package, or you will just buy the monitor of the computer. So we know that the money has a time value because its purchasing power changes. And how we are gonna measure this the time value? We are gonna look for the interest rate. The interest rate is the cost of or price of money. Like right now, with the, like, they are given like the inflation rate, or like when you go through the bank and then when you lend your money, they charge, I think, monthly like around 1.5 1.6%. Annually it's like, I don't know, like I don't remember, like 15-16% or something like that, right? So this is the how we can measure how we are gonna earn or lose money, because due to, like, if you are borrower, you are gonna earn money. If you borrow money, you are gonna lose because of you need to pay the interest rate. And if you lend your money to the bank, you are gonna earn due to the interest. All right. Let's see the methods of calculating interest. We have two different methods. The first one is single interest, the other one is compound interest. Single interest is the practice of changing an interest rate only to the initial sum or principal amount, which your capital. The other one is a compound interest, the practice of changing an interest rate to the initial sum and to the previously accumulated interest that has not been withdrawn. Which means, like for example, if you subtract your, if you lend 1,000 Turkish lira to the bank for 5 years with the single interest of 10%, okay, it means every year you are gonna get how many percent we said? 10%, okay. Every year you are gonna get 100 Turkish lira. But in compound interest, if you lend 1,000 Turkish lira for 5 years and for 10%, let's say 10%, the first year you are gonna get 100, then you will add this 100 to the 1,000, which is 1,100 Turkish lira is accumulated. Then you are gonna take this 10%, which is 110. Then you are gonna add again. It's gonna be 1,210. You are gonna take 10%, which is 121. Then you are gonna add, and then blah 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 till 5 years or how many years you put. So this is called compound interest. And if you take your principal, which is your capital, whatever you submit in the beginning, you need to take the interest rate according to this, corresponding this money. It's called single interest. Okay, let's have an example for simple interest, which is our principal is $1,000. Our interest rate is 8%, and our time duration is 3 years. Let's tabulate this one, and then let's see how we can calculate or how we end up after 3 years with 8% interest rate for $1,000. How much money is accumulated at the end of 3 years. I already prepared for the tabular form due to lack of time. So end of the 0th year, which is the beginning, so we don't have any balance, right? We don't have any interest earned, and ending balance is 1,000, which is we lent the money. End of first year, our beginning balance is 1,000, right? We start with the 1,000, and we interest earned from the 8% is $80, and the total of $1,080 we have. Then we will start again $1,080 at the end of the second year. Then we will get again the principal amount, which is $80. And as it is seen here, $1,160 accumulated in the bank, and we start with again $1,160, and we add 80, which is the principal amount, multiplied by 0.08. It's gonna be $1,240. Total of end of third year is accumulated in simple interest. Also, it's better to depict with the mathematical representation of this simple interest formula, which is the future value of the money is equal to principal amount plus the interest rate, which is you need to make it in the decimal form, Okay, if it is 8%, so you need to make it 0.08. Multiply the principal amount and you need to multiply the number of interest periods, which is like if the interest rate is given years, we need to multiply by the years. If the interest rate given in months, you need to multiply by the months. That's it. It's very easy to calculate for the simple interest formula. Okay, let's depict the compound interest with the same example, which is we have 8% interest rate and the loan is $1,000 and for 3 years. Let's see what happened in tabular form again. Again, we start with the $1,000 ending balance in the first year. And the end of first year, we are gonna have $1,000 and we will earn $80 interest, then end up with the $1,080. Then we bring here $1,080. We will take these ones 8%, which is 86.4. We add each other, and then we will end up at the end of second year $1,166.4. Then we bring in the beginning balance of the third year $1,166.4. Then we take 8% of this guy, which is $93.31. Then we add up is about $1,259.71 at the end of third year, which is in simple interest. What happened? It was $1,240, right? So in compound interest is you are earning more money than the simple interest. So sometimes the bank is giving this trick. So sometimes they are saying, okay, with the single interest, like we are giving like 5%, 10%, or like whatever, blah blah blah. So when they calculate, when they given you when they lend you, they say, okay, it's the compound interest. So like if you don't know these terms, you messed up with the math and you end up with paying more money but earning less money. Okay, when after we know the simple interest and compound interest rates calculations, let's go back our main topic, which is time value of money. Right now we are gonna find the present value, the future value, and we will define the series value. Let's go through all this one and let's see how we are gonna define, how we make the mathematical representation or the formulas for each definition of these terms. Before that one, let's again remember what kind of representation we are going to use. The interest formula for single cash flow we are going to use to formulate P. When you see P, it corresponds to present amount of money, generally T is equal to 0, and F is future amount of money, which is generally T is equal to N, the end of this time period. The I is interest rate, and N number of time periods. After we know this one, let's jump to our finding like future money with respect to present amount with the interest rate, how we are gonna do this, guys. Okay, first case is find future money given present money. So let's say we have like some sort of money, like $100 right now. After 10 years, what is this value in 10 years? Like we are in 2021 and 2031, our 100 Turkish lira with given interest rate, how much is gonna be? We will find this one. In order to find this guy, we need to find the single payment compound amount, which is future money is equal to present multiplied by 1 plus interest rates power of n, which is the duration of this number of years or number of periods. Okay, let's do example and then we can understand better this topic. As an example, an individual deposits 2,500 Turkish lira in a bank for 4 years. So we can say as a given P is equal to 2,500, right? And N is gonna be 4 years. 4 years. Okay, the interest rate, which is I, is equal to 6%. Compounded annually. How much money is accumulated this amount at the end of 4 years? Okay. What was our formula? The future money is equal to present money multiplied by 1 plus I power of n, which is future money is equal to present money, which is 2,500. Then we multiply 1 plus I, which is 6%, which is 0.06 power of n, which is 4. So it's gonna be 2,500 1.06 power of 4. If we multiply this one, we will get 3,155. 3,155 Turkish lira. So you guys can double check this amount. Okay. So like again, for the future, we are gonna get 3,155 Turkish lira. Is very basic math. Now let's find P, which is present money, with given future money. Again, single payment present worth is it's called to find this P is single payment present worth. The mathematical representation is given over here is the basically the same. P is equal to F 1 plus I power of minus number of periods. So when we put this guy here, we can find that the future value, if we plug in this same form, we can find the present value of the money. Let's solve one example again. In this example, a student is planning to save a trip to Europe. The trip will cost $3,000 and is planned to take 3 years from now. So the future value is of this trip is $3,000, and the N, the number of period, is 3 years. How much money should be deposited in a bank which pays 10% interest? So I is 10%. So it's asking the present value, how much we need to put. Okay, which pays 10% interest compounded yearly, so that 3,000 can be drawn at the end of the third year. Okay, question is given in this form. So we know that if we want to find the present value is the future value multiplied by 1 plus I power of minus n, which is 3,000, which is future value is given 1 plus 0.1, which is 10%, power of minus 3. So if we calculate this one, 3,000 multiplied by 1.1 power of minus 3 is given is around 2,253.9 dollars. So again, double check, make this process, and then find if I have any mistake. You guys can correct it. Right. Let's pass the another subtopic, which is if we want to find the future value with given A, which is annual series payment, and it's called uniform series compound amount formula, which is given F is equal to the annual series payment multiplied by 1 plus interest rate power of n minus 1 over interest rate is giving us the future value of this money. Okay, again, let's solve an example. We will understand this topic better. Okay, in this example, an individual is planning to deposit $500 every year for 10 years. How much money is in the account at the end of 10th year if the interest rate is 6% compounded annually? So A is given, which is 500. The duration, number of duration is 10 years. And the interest rate is 6%, right? Yeah, 6%. Okay, what was the formula? Our formula F is asking, right, how much money is in the account at the end of 10th year, which is future money, is A, which is annual series payment, multiplied by 1 plus I power of n minus 1 over the interest rate. So if we substitute all these variables, which is 500 multiplied by 1 plus 0.06 power of 10 minus 1 over 0.06. If we make all this process, we will end up by 6,590 $6,590.5. Dollar in the left hand side thing. Before going to any further, in this point we can add one more stuff. It's getting harder if we use these formulas one by one, because we are gonna go through the gradually increase and geometric increase, blah blah. So if we want to use tabular form, we are gonna use in this side. Like for example, if we want to use this one, F is equal to A multiplied by, in the parentheses, this is the function we are gonna give right now. So what I need to get is future value, which is here, right? This one, and I will divide it annual series, which is A cancel A, so it's gonna be F. Then the interest rate I will put here, and the number of periods. So this is the tabular form. The bank accounters using this formula, and they have a tabular form which I will show you later, and they just have the coefficient with respect to these numbers, and then they plug and then multiply by A, and they will get their result easily. This, as I said again, I'm gonna show you guys this tabular form later. The last topic for this week is to find present value with given the annual series. It is called uniform series present worth formula, which is given again. P is equal to annual series payment multiplied by 1 plus I power of n minus 1 over the interest rate multiplied by 1 plus interest rates power of n. In this mathematical formula giving us the present value of the annual payment. Let's see again example, and we will end up this week. Suppose a person will retire in exactly 1 year and want an account that will pay $20,000 a year for the next 15 years. Assume 6% annual interest rate, and what is the amount he would need to deposit now? So A for 15 years is $20,000 and the interest rate is 6%. As we said, the number of periods is 15 years, right? And we want to get it like this one. Let's draw first of all the cash flow diagram. Maybe we will get used to right now the cash flow diagram. So we want to submit a present value or like a principal amount at time 0. Then after that we will see, and after first year, second year, third year, blah 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 till 15 years we are gonna get a series payment, right? Series payment till here, which is all this one is, let's say A, which is 20,000 once. So if we add some money after 1 year, he wants to retire. This retired money is the first year. After the first year is gonna give, so he will earn his first year's 20 year. So like how much money he needs to right now add, then at the end of this 0 to first year, the beginning of first year, he will get 20,000 for this 1 to 2 years. Okay, we know the formula, which is P is equal to A multiplied by 1 plus I power of n minus 1 over I 1 plus I, right? 1 plus I, and is also power of n, which is 20,000. If we substitute all the variables, 1 plus 0.06 power of 15, because it's 15 years, minus 1 over 0.06 multiplied by, again 1 plus 0.06 is 1.06 power of 15. If we process these multiplications, and we will have the present value of this guy is $194,240. So he needs to pay, this is dollars, okay. He needs to pay around $200,000 right now in order to earn 20,000 for next 15 years with 6%, if the bank giving 6% annual interest rate. So we are done for this week. We saw how we are converting the value of money between each other, like the annual series, present value, and future value. Next week we are gonna see if we are adding the annual series with the gradually increase. Like for example, right now, like first year we want 100, then the next one, next year, the second year we are gonna get 110, the third year 120. This is arithmetically increased, or geometrically when like we are gonna give like a 10% increase, so it's gonna be 100, then 110, then 110's 10% is 121, something like that is gonna go. Like if we have a rate of increase, how we are gonna solve this kind of problems. And I will show you guys the tabular form how we are gonna use for this kind of problems. After we finish converting all these values each other, then we will jump to the analysis, which is present worth analysis, annual series analysis, and the rate of return analysis, which is basically if we have two or more options, which one do we need to choose? This kind of options we are gonna compare or evaluate, and we will end up our decision, and we will do it in this way. Okay, see you next week.